Hello everyone, welcome back to this channel. In this video, we will discuss a very important topic in steel design, that is modeling non-standard or custom built-up sections in STAAD using the Shape Editor tool. Now the discussion is divided in two parts. First part, we will focus on how to properly create a custom built-up section using Shape Editor inside STAAD and export it into STAAD Pro and use it effectively for structural analysis. Part 2, we will discuss the scope and the limitation of design of such sections and different way out to deal with those sections for design consideration based on different design codes. Now an important clarification on design instead. It is important to understand that when such section is modeled in the shape editor and exported as general section instead, the program can design it only as an equivalent ISEP section. So there is a very common question asked from the user on the same line, like if we have a custom or built-up section, can we design it instead? The answer is the design considering the exact original shape of an arbitrary section is not possible instead. That's because the design code itself do not provide section classification rule for any arbitrary geometries. The design code only defines the section classification and the respective design rules only for the standard shapes like I-shaped section, channel, angle, tubular, or T-shaped section. So any profile beyond this standard geometrical shape is not directly supported for code-based design instead. So whenever you are going to model those arbitrary section or the built-up section in the shape editor, this could be designed as an equivalent section. So for example, for AISC and Indian code, such built-up or general section can be designed as equivalent ISEP section, provided the user specifies the flange and the web thickness. However, in Eurocode, there is a special parameter that allows those general section to be designed not only as I-shape but also as channel, angle, tubular, and T-shape section. So there is a separate parameter for that, and we will discuss separately in a different video. So what STAAD still can do? Even though code-based design is limited, STAAD allows you to view stress distribution contour, check fiber stress across the cross-section. That enables the engineer to understand how stress varies in a very complex cross-section of a built-up section. This information is extremely valuable for applying the engineering judgment, especially to verify whether your extreme fiber stress is within the acceptable limit. Now the shape editor is new and powerful feature in STAAD, which replaces the older tool which we call as a section wizard. Section wizard was a similar kind of tool that we used to have in the previous version of STAAD. So some key advantages of shape editors are like ability to model very thin plate elements which are not possible in section wizard, accurate property calculation for cold form, steel and thin aluminum section which are generally based on the thin plate elements. Next, the retention of the actual geometric shape when exported as a general section, which helps the engineer to visualize and enables them to understand the stress distribution. So in this video, we will quickly demonstrate on how to create a custom section such as king cross section as an example using shape editor and export it instead as a general section and use it for analysis and see the stress result in the beam stress table. So the further discussion on designing such equivalent section with some codal references, we will create a separate video in continuation to the current one. So let's see the shape editor first.
So let's see how we can quickly create it. So we can use either the section from the standard library, that is from the standard steel table, or else we can use the standard shape from the standard shape profiles. That could be white flange, channel, equal, unequal flanges, and you can create different types of user defined shapes by combining different configuration. So in this case, let's say the white flange section. I'm taking one of the dimension here. So you can see three different elements for this eye shape is created. Now, once you do that, don't forget to right click and click on line to centroid. Okay, why it is important, I'll come a bit later. Now, if I want to place another section in the orthogonal position, what I can do, I can simply copy and paste, and I can manually just drag it by the mouse cursor at any location of my choice. In this case, I will rotate it by 90 degree to make it orthogonally positioned and want to place it at the centroidal location. Okay, so this is what we have for the built-up configuration. Now let's validate this section, because once you overlap one section over another, program needs to find some well-defined shape. It has to calculate some sectional property based on different polygonal properties. It first, for example, it should be closed. There should be some kind of internal angle guidelines, and there are certain computational geometry requirements. And for this, you need to validate. It looks like the section is good. Now, what we need to do next is analyze the sectional property by generating some meshed element. So what it is doing, why the meshing is generated, the program is calculating the sectional property of the cross section based on the cross sectional area that we have, and this meshed area helps us to calculate the sectional property very accurately, just like you do it in the finite element method to calculate the overall stresses. Same thing here, we are just calculating the sectional property based on the cross sectional area we have. So here you can see, once we mesh, the meshing seems to be okay for this region, but there seems to be some missing region where mesh was not generated. So for this, we would always recommend you to see this option. There are two different groups created, but these are not closed. So in those situations, what you need to do, okay, so what we need to do, we need to select first this element, the vertical eye shape, and then go to geometry, then click on ungroup. If you ungroup that you can see the group that was created by three different elements. This is the flange, this is the web, and this is another flange. So they all contributed to form a single element or single element group. So we have opened them. I'll do the same operation for the second set of element. So you ungroup the second set of element as well. Now you can see all the rectangulars are all isolated. Now simply you need to go to section and click on this one, convert to closed polygon. All of them you can see here are converted to the closed polygons. Next you can go to the merge polygon. Now all the polygons are merged and overlapped regions are also been merged. So you can see here the polygon is well generated. Now this time let's take this option to validate. The geometry looks good. Now let's analyze by generating the mesh. Now this time you can see the mesh has been properly generated, uniformly generated all across the different areas along the section. So that indicates that my section is good enough to calculate the section property very accurately. And all the section properties are calculated based on the cross-sectional geometry that we have. So next what we can do is we we can go to File, and there is something called Export. If you go to Export and click on Profile UPT, you could see there are two different options while you transfer those information to the STAAD environment. First is the prismatic, second is the general. So we always prefer to select the general if you want to retain the geometrical identity, geometrical shape back to STAAD Pro. If you select prismatic, it is also good. It will carry all the different sectional properties, but its original geometry would be discarded, and a rectangular, equivalent rectangular section would be transferred to STAAD. So I would prefer here the general because I want to show you the original geometry being transferred and how it can be analyzed, and how the stress distribution can be visualized in STAAD Pro. So what we do next is go to select, and you select a location. Let me select this location, maybe any location if you want. I'm randomly select one location here, and you give a name like X, correct, for X section, and you click on this. So your section name is defined along with the entire path where your UPT file would be saved. Now the default section name here is section name, so we may also replace it by giving it like X sec 1. Let it be general, and the unit be inch or millimeter. It's up to you to select. Now I'm not changing anything. Now here you can see that all the sectional properties are calculated, but these are all grayed out. Now if it is grayed out and if you want to change it, you have to go inside the input editor file and you can manually change in case you want to, or else let it be the actual sectional properties as calculated by the program. So if you click on this, you can see the message would pop up like shape exported successfully. So at this point, I'm not closing this. You can simply minimize this, and you open the respective STAAD model. And first you need to go to user table like this, and there you can go to external file, go to browse, and go to the same folder where you have saved your UPT file. This is my UPT file xsec.upt, and you just click on OK, and that's it. So the name that was saved inside that UPT file for that particular geometry, that is xsec1, is highlighted. So you need to just save it, go to the user table, and this is your section. So click on add. Now I have already created some of the other section before, so I'm just removing it so that I can reassign it and show it back to you. So this is the section that we have just imported from Shape Editor. And if we show the view of this in the 3D rendered generation, it looks like this. You can see here. This is exactly what we wanted and what we have created in the Shape Editor. That is the grain cross section. Now let's see if I can successfully run this model. So the analysis looks fine. So if I want to see the beam stress for that particular section, I need to go to this layout, and there is something called beam stress. Now this is the section. Let's zoom this, and if you place this slider and drag like this, it will run all across its length, and the respective sliced section would be shown here. The stress representing at the respective slice section would be shown in this colored contour. Now here you can see if I keep on dragging up and down, my color contour gets a little bit of changed. You can see the formation of blue and red color got a little bit of changed if I drag across its length. Now that indicates the variation of stresses at those zones all across its length. Here the red indicates it's in tension, blue indicates it's in compression. So the stress values at the respective node would be shown here. Now default node is at the centroid. Now if I want to pick any node, say for example I want to pick any node at extreme fiber, you just need to just click here with this cursor, and here you can see the respective node was picked and the stress is also reported here. Now if I drag the slider like this, you can see the stress value is also changed. Now this stress profile is also shown here. You can also control this selected stress profile node manually by inputting the values from here, or else you can pick it from the graphical user interface. Okay, so whatever we have here, we need to just click on this add stress to table. So what it will do, we'll just have a look. So those stress values would be shown in this table, and if you want to see more stresses at different location, you can see all those values, but this value would show you the maximum stresses all across its length for the selected stress point. Our stress point is here. So by this way you can evaluate for any non-standard section, although this could not be designed. The reason already I have explained before. You can understand like, okay, due to those variation in the fiber stresses, how much is the stress experienced by the extreme fiber, and whether these are all good for my allowable limit or not. How to set those allowable limit are all those things you can have your engineering judgment, or if you have any other guidelines, maybe codal guidelines, or maybe any other rules, you can use them. So this is how you can create any non-standard section in Shape Editor, and you can bring it back to STAAD, perform the analysis, and visualize its stress diagram. Thank you. If you have any further question, please post in the comment section. I'll try my best to address them as soon as possible. Stay safe, stay tuned. Stay tuned, stay safe. See you in the next video.